So, I'm going to talk about something really, really sexy. Yeah, computers can be sexy. DNS. Raise of hands. Who knows what DNS is? Ooh, that's good. That's good, but not everyone. Not everyone. So, what does DNS stand for? Domain name service. Good, good, good. All right, so let's all read about this. This RFC, I'm just joking. I wouldn't do that to you guys. I wouldn't do that to you guys. That's what an RFC is. I wouldn't bore you with that. So why do we need DNS? Oh, come on, people. We can go to websites. Okay, when we go to websites, what do we like to do? What do we like to do? Browse, yeah, look at pictures and videos and stuff. But when we go to a website, what do we type in? Names. We love names. We don't like numbers, right? If I was to call out, I was going to say, hey, you. You're going to be like, who, me? Me, right? We don't go by numbers, right? We're not like Jean Valjean from Les Miserables. We're 2 for 601, right? So we like to have names. I always have names. Now, if you're old like me, you still probably remember your grandmother's telephone number, right? You still remember, I know 3 numbers. I know my home number when I was a kid, my grandmother's number, and my first girlfriend's number. Nowadays, I don't even know my number in my home, right? Because I just push that little icon on my phone and it dials it, right? So what we did before, the godfathers of the internet, right, is they realized that people like to do names to these computers. And what do computers usually have? How do we identify, how do we get to a computer? Does anyone know what that's called? An IP address, right? Internet protocol, right? So we're up to IPv6, not really widely used in the United States yet. It's going to get there by the time I'm 150. But IPv4, you guys all heard of that before. It's like those 4 little octets of numbers, a 32-bit number, right? And that's how computers talk to each other. But we need to have some sort of translation from name to IP, right? So the godfathers of the internet, and my pointer's not working, but the godfathers of the internet decided that we're going to need to do this. And what they did originally is have something called a hosts file. And I kid you not. This was a file that someone manually updated every single night, and they shared this from university to university to company, and that's how they got to each other's websites. Right? People would modify it, and they'd share it over their bulletin board systems. They dial up once a night and download it. Yeah, there was dial-up back then. Who doesn't even know? But too many people don't know what that is. But I remember I was dialing in with my Trumpet Windsock client, and I would actually download this little file. But anyway, at a certain point, we realized that there's a lot of computers that are going to connect to this crazy thing called the internet. And sharing a file was not going to work out right. So what we decided to do is come up with something called DNS. So let's visit 2 different companies. Opportunity at Work, once again, a sponsor for this event. Thank you very much. And also opaque.com also have done many things with us before. And Alex right there from Opaque, so I will push them. And so let's say we had a computer and we wanted to go to opaque.com or opportunityatwork.com. Right? And we make this request in what? What sort of thing do we usually make this request in? A web browser. This is a fully interactive demo. So feel free to jump out and say, if you're wrong, I will not laugh at you. At least not now. I will later. No. So what we're going to do is we make it in a web browser, right? And this web browser has to make a request to what? What does the web browser run within? It runs within an OS. Oh, this is good. See, this guy's brownie points. All right, and then what does the OS do? Any idea? Well, we're going to talk about that. And this is where the DNS comes in. So what we decided to do when they said we can't keep sharing this host file, we're not going to have everyone download this file. It's probably going to be, people started putting the wrong IPs. People started changing it. People started making mistakes. We're going to make some sort of distributed system that's going to take care of all this. So what every operating system has, Mac OS, Android, Windows, Linux, you name it. It has in your configuration what's called a resolving name server, or you can call it a recursive name server, right? And so all this system's responsibility for is to give you answers, give you names to IP, name to IP, name to IP, right? So let's just talk about this. So the query goes from your browser to your operating system to the recursive name server, and the recursive name server then has to figure out where to go. Now, the only thing the recursive name server knows is what? My whole entire staff should know this. But that only knows what? Anybody? I put it on the screen. You can just read it. No, it knows the root name server, right? So when you actually go to opaque.com or you go to google.com, you're actually going to opaque.com dot, right? You're actually going to google.com dot. Right? And you can say it like that, and it means a lot more. So when you go to and that's actually the dot. And most people, you guys ever try it? No, do it tonight. It's really fun. You get to the exact same website. But what that means is you're actually going to the root of the internet, right? And so your browser automatically adds that to it, sends it to the recursive name server, and the recursive name server, the only thing that knows is where the root name servers are. Now, there's 13 root name servers. Why is there 13? Pop quiz. Come on. Yeah, you're getting the reason why it's all that fits in what's called a UDP packet, right? So we're all bound by limitations on how the internet goes. So there's 13 root name servers. They all used to be run by the United States, but now they're kind of distributed all over the world. They're done on what's called IP Anycast and everything like that. And there's different organizations run different ones. Predominantly at one point, 9 of them were within the Washington, D.C. area here. Yeah, we started the internet. Okay, so what happens, this recursive name server actually goes to this root name server and says, hey, I'm looking for www.opaque.com or opportunity.work.com. What do you think this guy says? Oh, come on. Okay, it's going to say, I don't know, I have any idea, but I know where com is and I know where org is. Right? And that's all it's going to do. It's going to say, hey, I don't know, but I know where to find, I know something, right? And that's what the root name servers are responsible for. They're responsible for just responding who's in charge of the top level domains from there on, right? And so then this recursive name server gets that information and says, okay, where's www.opportunity@work.com or where's www.opaque.com, right? And what do you think this says? It says, I don't know an idea, but I know where to find the next step. And it goes through this next step, right? And then you go to, and then it hits what's called the authoritative name server, right? And this recursive name server says, okay, where's www.opportunity@work.com or www.opaque.com? It comes back and it says, here's the IP address. Bingo, I finally found this damn thing, right? I had to do 1, 2, 3, 4 lookups just to get this IP address. And that's done in less than the blink of an eye. We talked about internet performance, right? Our previous presenters today talked about page load speed times, everything like that. It's actually proven. Your DNS lookup time is over 200-300 milliseconds. Your whole page just starts slowing down. So what happens then? It comes through all these different lookups. It goes to the recursive name server. The recursive name server then gives it back to your operating system. Your operating system then gives it to your web browser, and then your web browser makes a direct connection to that IP address and says, hey, I'm looking for this website at this name. Show me something. And then it makes a TCP IP connection over user HTTPS, gives all that data and brings it back. So that is, in less than 10 minutes, Neve, how DNS works. And I'm finished. That's it. So, on that note, any questions? There really can't be. No questions? All right. So what we want to do, you have a question? Why is .com raised? Ooh, anyone from VeriSign here? I don't want to say anything. Okay, so VeriSign, how the internet was founded is that certain organizations had the ability to take control over certain namespaces. VeriSign is actually runs .com and .net. They're based right here in Reston. .org was run by Public Information Registry, PIR, which is like 2 blocks from here. They just sold recently, so their pricing's going up as well. And so what the thought is with the .com is that they're believing that the costs to serve that namespace is going up, so they're increasing the .com pricing, and I think it's going to be pretty drastic, right? I mean, at one point, .com registry pricing was down to about $4 or $5. Now it's around $8, and they're expecting it to go up to about $11. That's the registry price. So then the registry buys it. You buy from GoDaddy, they're the registrar, right? So you buy it from a registrar. That's who we buy domain names from, and they buy it from the registry, and they run these .com name servers all over the world. So they believe that the cost of the infrastructure and the cost to offer that service is going up. And so that's that. So I have friends at VeriSign, so I'm not going to say anything negative about that. But anyway, any other questions regarding DNS and how the whole lookup process works? No? You do? How do you... So how do you get fast DNS? Well, you choose a provider that starts with the letter C, ends with the letter X, and they will actually provide you IP Anycast DNS. That's actually what our company mainly does. We provide IP Anycast DNS services over 1 million domain names. We do really cool stuff with routing. We'll make decisions based upon clouds and move stuff based on... It could be down to your cell phone, right? We'll track people to Amazon here, Microsoft here, second by second, and move it, whoever's faster for you. Any other questions? Cool. All right, so we're going to start what's called the lightning round. One more question?
At the beginning, you mentioned that this is the process that you ignore.
Oh, yeah. You see that? Okay. So there's been a couple things out lately. Let me see that. Sarah's got the good eye. There's Jean Valjean. No, bring me prisoner for 601. Okay, forget DOH. DOH is DNS over HTTPS. The cool kids call it DO. And there's also DNS over TLS, which is called DOT. So DO and DOT, and we're kind of like DO, a dear. We actually, there's DNS meetings. We actually sit around and sing those songs. But what DO is actually DNS over HTTPS, and so that's just been pushed out recently. If you have a Firefox browser, it's now making a direct connection to a Cloudflare resolver because the world believes that if you don't give the DNS lookup to your ISP and they can't see it, it's safer to go to Cloudflare. I don't get it. But some people believe if you give your organization, you give your data to some organizations, they're going to be safer with it than if you give it to the people you've been giving it to your whole entire life. And so I don't get it. We can get into that conversation all day long. But that's what DNS over HTTPS. So what this process does now is if you have Firefox, you weren't even given the right to change that. You actually have to change your browser now. All your lookups are going to one organization where they're now taking it and selling it and marketing it for you. So that's what Cloudflare does. So, and you agree with me? Yeah, all right. So any other questions? All right, cool.